Hey, this is Mr. Nuez, and today I'm going to take you through part 6 of your notes, analyzing and interpreting. You can find these on the third page of your notes packet towards the bottom. So turn to that page and follow along and fill them out as we go through. The learning targets that apply to this section of notes are: I can read a graph representing data collected in an experiment. I know the differences between bar, line, and circle graphs. And I can build a line or bar graph to represent the data I collect in an experiment. First, we're going to talk about creating graphs. And a graph is a picture that helps you and others understand data at a glance. Most graphs have all the same basic parts. And we're only going to create a graph if it's appropriate for our experiment. To create a graph, the manipulated variable always goes on the x-axis or the horizontal axis. The responding variable always goes on the y-axis or the vertical axis. So on our example here, the x-axis would be where the labels are, and the y-axis is where the label units are. Easy way to remember this is with the words dry mix, where the D in dry stands for dependent, the R stands for responding, and the Y tells you that it goes on the y-axis. The M in mix stands for manipulated, the I for independent, and the X tells you that these variables go on the x-axis. Bar graphs are used to compare numbers and describing data. The describing data is labeled on the horizontal axis, or the x-axis. The number data is marked on the vertical axis, or the y-axis. Each object has a vertical bar. Pie charts, or circle graphs, are used to give a quick view of the relationships among parts of a whole. Values in a circle graph always add up to 100%. Line graphs show the relationship between two numbers as those numbers are changing. Both axes of a line graph can show number data. Steps for making a graph. First, you're going to label each axis with a value and a unit. Then you're going to mark the axes with scales, or equally spaced marks. You want to make sure you choose graph scales so that the line of your graph is neither too short nor too long. Choose an interval that is easy to read and makes sense for your data. Now we're going to watch a quick video by BrainPop on graphs.
Cruising around the Caribbean in search of adventure. This sure is the life, isn't it, Moby? Whoa, what's this? Welcome, travelers. We have learned that you are searching for the monster of youth. Follow these clues and eternal childhood will be yours. Monster of youth? Never heard of it. But, well, okay, let's do it. For your first task, you must find your way to the Caribbean nation with the most ducats. Ducats? Oh, money. Well, sounds like a job for my trusty World Factbook. You can find anything in there. Let's see. Caribbean countries with the coolest flags. Caribbean countries with the most spectacular shipwrecks. Here it is. Caribbean countries with the highest gross domestic product. Oh, well, that's a measure of how much money a country has. But this list of numbers is all garbled and confusing. Maybe we should use a graph to help us visualize which one has the most, ducats. I'm thinking we can use a bar graph. First, we list all the independent countries of the Caribbean along the bottom, or x-axis, and on the left-hand y-axis we mark off levels of, ducatage. We could use the graph to compare values of money per person for each country. Looks like we're headed to the Bahamas. Wonder what we do now. I really want to find the monster of youth. Well done. For your next clue, you must find the Bahamian island with the largest area compared with the area of all the Bahamas combined. Godspeed. Who's sending us these things, and how can they see us? Well, let's go back to my fact book. I have a listing here of the biggest islands of the Bahamas, sorted by area. I think we should use another graph to help us see it more clearly. Since we're graphing pieces of a whole, let's use a circle graph, or pie graph. Right, the island of Abacao has 1,680 square kilometers, Acklands and the Crooked Islands have 520 square kilometers, Andros has 5,960, and so on. Andros Island has the largest slice, so I guess it's the island with the largest area. Off to Andros, my good man. I don't see any birds. I wonder if we made a wrong turn. Okay, just an octopus, nothing to see here. You have proved yourselves worthy seafarers. For your final task, you must disembark and find the nest of the fabled Bahamian Chickcharnies. Once there, you will encounter the legendary monster of youth. Cheerio. What the heck is a Chickcharnie? Where are we going to find one? Yeah, me too. I'm starting to wonder whether these Chickcharnies exist at all. I mean, I'm all for finding the monster of youth, but then what's the point if it's going to take us forever? Let me double check my fact book to see if they even exist. Well, according to this line graph, the number of Chickcharnie sightings has decreased steadily over the last 300 years. Yeah, see, the number of sightings is plotted against the scale of years from earliest to latest. You know, Moby, they could be extinct. What was that? Could that be it? It's so funny looking. Hello, we're looking for the monster of youth.
I am the monster of youth, but I'm afraid you're too late. My powers of granting eternal youth are all used up. I can only sit around these fair forests, sending parchments to youngsters like yourself and offering words of wisdom instead.
Okay, so what wisdom do you have for us?
One word. Plastics, my dear boy. Plastics.
Plastics? Gee. Thanks.
Alright, so now let's take some time in your notes packet to answer the following questions on the Brain Pop video. Remember, you can pause this if you need to spend a little bit of time doing this. So what is one good reason to use a graph? Go ahead and write down your answer in your notes. Second question, which line is the x-axis? Third, which graph would you use to show how something changes over time? now we're going to talk about analyzing our results. Once your graph is made, you're going to look for trends or patterns that help you answer your question. Analyze your data to determine the final outcome of the experiment. Does your data support or refute your hypothesis? Your data should help provide a preliminary answer to your question. Once you've looked at your data, you might need to gather more data or change how you have collected it. Alright, so now we're done with this section of the notes. Make sure you turn these in so you can get credit for them. And then we're going to have several graphing activities coming up in class for you to practice your skills.